Friends, in this video, we work out problems on the continuous probability distributions. Already told you that the problems are problems on the evaluation of integrals. Now, first problem is find k such that the function p of x equals k into e to the power of minus mod x, comma, minus infinity less than x less than infinity is a PDF of a continuous probability distribution. Probability distribution. Also find its mean and standard deviation. Also find its mean and standard deviation. So that means here you have to evaluate three integrals. So we know that the condition for p of x to be a probability function is it has to be non-negative, and the integral value from minus infinity to plus infinity equals to 1. So we'll use that condition to determine k. The condition is integral minus infinity to plus infinity p of x dx equals 1. That is integral minus infinity to plus infinity k into e power minus mod x dx equals 1. Now how to evaluate this integral? So we have got modulus. You know the modulus function is such that mod x takes the value minus x whenever x is negative and plus x whenever x is positive. Okay. Now, so you have to split this into two integrals. Instead of that, we can use the property of definite integral. Here, the function p of x equals k e power minus x satisfy the condition that p of minus x equals k into e power minus mod x, which is same as k into e power minus mod x, which is same as the given function. That means the function is even. And therefore, by property of a definite integral, the integral reduces to twice integral 0 to infinity k into e power minus x dx. Now here I replace mod x by x because in the positive interval 0 to infinity mod x equals x. Now I can evaluate this integral easily. Take k outside. Taking k outside, we get 2k integral 0 to infinity e power minus x dx equals 1. Now, so simple integral. You know that integral of an exponential function is just that exponential function divided by the coefficient of x, which is just minus 1 here, and limits between 0 and 1. And if we take the limits, I'll take minus outside, minus 2k into, put x equals infinity, you're getting e power minus infinity. Strictly speaking, you can't write like e power minus infinity. We have to write limit as x tends to infinity e power minus x. For simplicity, we can write like that. And we know the value of e power minus infinity, which is 0. And lower limit is x equals 0. So it becomes e power 0, or the lower limit equals 1. But e to the power of minus infinity equals 0. Therefore, we get minus 2k into minus 1 equals 1, that is 2k equals 1. Therefore, k equals 1 by 2. That means for k equals 1 by 2, the function becomes probability density function of a continuous probability distribution. Now, we'll find out the mean. So, mean equals mu, which equals to expectation of x, which is nothing but integral minus infinity plus infinity x into p of x dx. Here p of x is nothing but the function k is 1 by 2 into e power minus mod x dx. Now, this function x into e power minus 6 is an odd function. Therefore, by property of definite integral, this integral equals 0. That is, mu equals 0. So, don't try to evaluate the integral by splitting into two parts, minus infinity to 0, 0 to infinity. Just use the property. Okay. Now, next we find e of x square, that is expectation of x square, which equals integral minus infinity to plus infinity x square into p of x dx. And what is the p of x? Which is nothing but 1 by 2, 1 by 2, I'll write it outside, x square into e power minus mod x. And we already shown that this e power minus mod x is an even function. X square is, you know, that even function. So the product is an even function. Therefore, the integral becomes twice 1 by 2, that constant present, into twice, the integral becomes twice 0 to infinity x square into e power minus x dx. 2 cancels. Now, how to evaluate this integral? You have studied you use this extensively in the third semester in the Fourier series, that is the Bernoulli's rule. Just we have used that rule. Since you already studied, I am not mentioning about the rule, we simply use that one. So x square is the polynomial, e power minus x is the integrable function. Now using the Bernoulli's rule, we are getting these three terms. Keep x square as it is for the first term. Integral of e power minus x is e power minus x by minus 1 minus. Now differentiate x square for the second term. You are getting 2x into integrate e power minus x by minus 1 again. You are getting e power minus x by minus 1 whole square. So whole square is plus 1. Next term is plus derivative of 2x. That becomes 2. And integral of e power x by minus x whole square, that is e power minus x by minus 1 whole cube. Okay. Now, we have to take the limits. So, we can easily show that the limits of the first two terms is 0, because at the upper limit is 0 because of e power minus, at the lower limit is 0 because of x square here. Similarly, the second integral value equals also 0, because second term at upper limit 0 because of e power minus x, lower limit at lower limit is 0 because of x. Now just we have to take the limit for the last term. There minus 1 whole cube is minus 1. So taking it outside, I am getting minus 2 into e to the power of minus x between limits 0 and infinity. Now this is equal to minus 2 into, put x equals infinity, e power minus infinity minus e power 0. And we know that the e power minus infinity is 0. So neglecting that, you are getting minus 2 into minus 1, which equals 2. That is variance sigma square equals 2. What about standard deviation? Standard deviation is nothing but square root of the variance, that is sigma, which equals root 2. Okay, just evaluating these three integrals, we are getting all the required things: k, mean, and the standard deviation. Now, it is a continuous function or non-splitting function. If you give a splitting function, then you have to evaluate more integrals. That we'll see in the next problem. Now, the next problem is, if PDF f of x equals k into x plus 3 in interval 2 comma 8, not infinity, sorry, it is 2 comma 8. Determine number 1 k, number 2 p of probability 3 less than x less than 5, number 3 probability of x greater than or equal to 4, and number 4 probability of mod x minus 5 less than 0.5. A very interesting problem because all the kinds of interval we come across here. Fine. So first we consider the PDF, which is the function k into x plus 3, but it is defined only in the interval 2 comma 8, but actually we require the function in the complete interval. And you can notice that instead of p of x, what is given as a PDF in the previous one, the notation what is given for the PDF here is f of x. Fine. So now, so let us consider this function the complete interval. Now, what is the other part of the interval which make up the minus infinity plus infinity, the real line? The interval which is comes before 2 comma 8, which is the interval minus infinity to 2, minus infinity less than x less than 2. In this case, the function is 0. It's not given. We can take it as 0. And in the interval 2 comma 8, it is k into x plus 3. K into x plus 3 in the interval 2 less than x less than 8. And after that, one more interval is 8 to infinity, and it is also 0 there. This is a given function, okay, which is a splitting function having three different terms. One is this, other interval is this, other interval is this. Now, so therefore, we have to split the given integral which you get from definition into three integrals. Fine. Now first we will find out k. To find out k, we use the condition that integral minus infinity to plus infinity f of x dx equals to 1. That is. So this function is splitted. Therefore, you can't substitute for f of x directly. Therefore, split the integral into three integrals, namely minus infinity to 2. There, what is the value of the function? 0 plus next integral 2 to 8. There, k into x plus 3, and next integral is 2 to infinity. Sorry, 8 to infinity. In that case, the value is, okay, so integral 8 to infinity, there the function is 0. So the first and last integral goes off. Okay. So just we evaluate the remaining integrals. There is only one integral. There k is the constant, take it outside. Integrate x plus 3. You can integrate in two ways. Simple as this. X plus 3 whole square by 2. Or you can integrate term by term. What are the limits? 2 and 8. 2 and 8. So you are getting k by 2 into. So if you put x equals 3, you are getting 8 plus 3. 11 square minus, put x equals 2. 5 square. Simplify this. If you simplify this, okay, so this is equal to 1. This value must be equal to 1. So simplifying this, you are getting k by 2 into 11 square minus 5 square, which simplifies to 48. 121 minus 25. 121 minus 25 equals to 1. That is k by 2 into 96. This becomes 96 equals 1. Therefore, k equals 2 by 96, which is nothing but 1 by 48. This is the value of k. Now, next we find out probability over an interval p of 3 less than x less than 5, which equals to integral 3 to 5 f of x dx. Now, so what I have to substitute for the function f of x? Do I have to split this integral? No, not to split the integral, because go back to the function. So 2 to 3 to 8, 3 to 8 is a part of this interval, the given interval. So therefore, the value of the function here is just the k into x plus 3, and we have got that k as the value 1 by 48. Therefore, we can substituting for that, we are getting that integral 3 to 5 1 by 48 into x plus 3. Now the integral is simple, we already done it, only the limits are different. 1 by 48 into x plus 3 whole square by 2. Take the limits. Take limits. You are getting, and simplifying, you are getting it as 3 by 4, because 1 by 96, 48 into 2, put x equals 3. 3 square, that is 36, minus, put x equals, sorry, upper limit is 5, lower limit is 3, no? So if you put x equals 5, 5 plus 3, 8, 8 square. 8 square is the thing about 64, minus, put x equals 3, 3 plus 3, 6 square, which is nothing but 36. And 64 minus 36 is 28. 28 by 96. Then if you're dividing by 4, 4 sevens are, or 4 twos are, 4 fours are, 7 by 24 is the answer. Now, so in the same way, we have to find the next two probabilities. So P of x greater than or equal to 4. Now, here what you have to do is, we have to write this thing as P of 4 less than or equal to x less than infinity, because we never given x greater than something, then the interval is from that to infinity, which can be written as integral 4 to infinity, by definition, f of x dx. Now you have to split the integral, because so the function is defined from minus infinity to 2, 2 to 8, 8 to infinity. You have to split the integral as 4 to 8. In that case, the value of the function is k, that is 1 by 48 into x plus 3. And next is integral 8 to infinity. Value of the function is 0 there. So the second integral becomes 0. First integral evaluated, same as the previous one. Only thing is upper limit is instead of 5 you got 8. Instead of lower limit 3 you got 4. Evaluate and simplify. You get the answer as 3 by 4. It's simple. You can do it on your own. Now, so the next one is slightly different. The interval what is given is slightly different. Now, let us consider this one, which is probability of mod x minus 5 less than 0.5. Okay. Now, here you are given modulus. Modulus means mod of some function in x less than k, means it is the interval minus k less than f of x less than k. Therefore, using that, we can write this thing as p of minus 0.5 less than x minus 5 less than 0.5. Now, adding 5 throughout, we get p of 4.5 less than x less than 5.5, and from definition it is equal to integral 4.5 to 5.5 the function p of x or f of x, in this case written as f of x dx. Now, so this is also a part of the interval 2 comma 8, therefore I can directly substitute for the function p of x as that k, which is 1 by 48 into x plus 3 dx, integrate 1 by 48 into x plus 3 whole square by 2 between limits 4.5 and 5.5. So same as the previous one, only the limits are different. Simplify, taking limits, you are getting it as 1 by 6. Okay. Now, next we consider a slightly different kind of problem where we are finding the CDF by knowing the PDF, and using that CDF we evaluate certain plot over certain intervals. Okay. The problem is for continuous PD means probability distribution having P of x equals, which is splitting function x in the interval 0 less than x less than 1, 2 minus 6 in 1 less than equal to x less than 2, and 0 otherwise. Find CDF and hence evaluate probability of x less than 0.5. Number 2, probability 0.75 less than x, 1 minute, 0.75 less than x less than 1, and the third case is probability of x greater than 1.5. Okay. Now you're asked to find out CDF. By definition, CDF equals f of t, which is given by the integral minus infinity to t, that function PDF, which is p of x dx. But you can't substitute for this p of x directly because it is a splitting function where function p of x is defined in different intervals. Now first let us rewrite that function p of x covering the complete real n minus infinity plus infinity. Now here the otherwise means it is having two intervals. One is the interval which comes before the 0 to 1, which is minus infinity to 0, and the interval which comes after this 1 to 2, that is 2 to infinity. That means the function p of x can be written as p of x equals 0 in minus infinity less than x less than 0, x in 0 less than x less than 1, and 2 minus x in 1 less than equal to x less than 2 and 0 in 2 less than x less than infinity. Now we have to consider t belong to all the four intervals. That means first we have to consider t in the interval this. That is t belong to interval minus infinity 0. Then t belong to interval 0 to 1. Then t between 1 and 2. Then t between 2 and infinity. Okay. Now first let us consider the first interval where t is belonging to minus infinity to 0 for minus infinity less than x less than t less than 0, f of t equals integral minus infinity to t p of x. Now since t is here in this interval, okay, so we will take only one expression, that is 0. So it is minus infinity to t 0 dx, which equals 0. Now next, for 0 less than t less than 1, f of t equals integral minus infinity to t p of x dx. Now t is here, is in this interval. Therefore, we have to start from minus infinity and then we have to split the integral as minus infinity to 0 and 0 to t. So it becomes minus infinity to 0, 0 there, plus 0 to t, x there. Now evaluate this. The first integral is 0, that goes off. Look at the second integral. Second integral, evaluating that, you are getting x square by 2 with the limits 0 and t, and if you take the limits, you are getting t square by 2 minus 0 square by 2, that simplifies to t square by 2. Now consider the next interval for 1 less than t less than 2. The CDF f of t equals integral minus infinity to t p of x dx, which has to be splitted as minus infinity to 0, value of the function is 0 there, plus 0 to 1, value of the function is x there, plus 1 to t, the value of the function is 2 minus x there. Now, we have to evaluate these two integrals. The first integral is 0, neglect it. Second integral, integral of x is x squared by 2. Limits are 0 to 1. Then, integral of 2 minus x is 2x minus x squared by 2. Limits are 1 and t. And if you take the limits, you are getting 1 squared by 2 minus 0 squared by 2 plus. So you have to put x equals upper limit, which results in 2t minus t squared by 2 minus. Now put x equals 1. 2 into 1 minus 1 squared by 2, which simplifies to 1 by 2. 1 by 2, this is 0, plus 2t minus t squared by 2, then minus 2 plus of, which simplifies to minus t squared by 2 plus 2t. The constant minus 2 plus of reduces to minus 1. Next interval for 2 less than t less than infinity. f of t equals integral minus infinity to t p of x, which has to be split into four integral. It is integral minus infinity to 0. Function is 0 there, plus integral 0 to 1. Function is x there, plus integral 1 to 2. The function is 2 minus x there, plus integral 2 to infinity. The function value is 0 there. So here the first integral and last integral vanishes. Remaining integrals, if you integrate, you are getting x squared by 2 between limits 0 and 1, plus 2x minus x squared by 2 between limits 1 and 2. Now taking limits, we are getting 1 by 2 plus 4 minus 2 squared by 2 minus 2 minus half, which simplifies to 1 by 2 plus 4 minus 2 minus 2 plus half, which is equal to 1. 4 minus 4 cancels, half plus half, which is equal to 1. Now, so therefore the function CDF is f of t equals f of t. So 0 for minus infinity less than t less than 0, t squared by 2 for 0 less than t less than 1, minus t squared by 2 minus t squared by 2 plus 2t minus 1 for 1 less than equal to less than 2 and 1 for 2 less than t less than infinity. Now, using this, we can easily find the values, probability of different intervals which are asked in the problem easily. The first one, p of x less than 0.5 equals, by definition, is nothing but f of 0.5, and 0.5 belongs to this interval, namely 0 to 1. Therefore, what you have to do is you have to take the corresponding expression, namely t squared by 2. There we have to put t equals t squared by 2. You have to put t equals 0.5, which equals 0.5 whole square by 2. Simplifying this, we get the required value. Next, next one is p of 0.75, less than x less than 1 equals f of 1 minus f of 0.75, which equals 2. Now here, 1 belongs to this interval. Therefore, you have to consider this expression. Therefore, put t equals 1 there. That is minus t squared by 2 plus 2t minus 1. There put equals t equals 1. Then minus f of 0.75. 0.75 belongs to this interval, namely 0 to 1. Therefore, t squared by 2, there put t equals 0.75. Then simplify this to get the required value. Last one is p of x greater than 1.5, which can be written as probability of 1.5 less than x less than infinity, which can be written as f of infinity minus f of 1.5. F of infinity is nothing but 1 minus f of 1.5. 1.5 belongs to this interval. 1.5 belongs to this interval. Therefore, putting t equals 1.5 there, which is 1, okay, which you are getting 1 minus 1, that is 0. Okay. So this completes all kinds of problems, and problem is left for exercise in the notes. Try that problem, and you can easily uh, work over the problems with this idea. Okay. In the next class, that is the next video, we learn particular cases of this. Exactly, the next video I'm taking a simple particular case, namely exponential distribution or negative exponential distribution.